Top of the morning! My name is Ruchir Talasu, and today we will be doing for math student solves. We are going to be doing question number 22 in the 2018 Algebra 2 individual, and this was during the January regional. Alright, the question itself. Evaluate the square root of 63 squared plus 84 squared plus 252 squared. Now, you could either do this the hard way and find the square of each number, then add them together, then find the square root of that, but that is very time consuming. So, we want to simplify this, right? We want to make this problem easier for us to do, less taxing, right? So, here's the question we should be asking ourselves when we see a problem like this. Can the numbers, in this case, 63, 84, and 252 be simplified by a greatest common factor? Alright, a greatest common factor. I'm pretty sure you all know what that is, but just in case you don't, a greatest common factor is the biggest number in which all three of these numbers, or any given number, right? All three of any given number, or no matter how big it is, can be divided by. Alright, now in this case, I can already tell you that we cannot divide by any even numbers. No even numbers can be the greatest common factor. Why? Because 63 ends in the number 3, and as far as I know, no even number before 10, so no single digit number before 10 that's even can be, divided by a number which has 3 in its unit digit. So let's start. Number 1, obviously all numbers can be divided by number 1. Really isn't much of an issue, so we can just throw that to the side. Alright, then we have number 3. Hey, look at that. 63 divided by 3, you get 21. 84 divided by 3, guess what? You get 28. And then 252 divided by 3, you get 84. So what do we find out right here? We find out, well, guess what? We find out that 3 is a number in which all of these numbers can be divided by, which is actually pretty good for us. Alright? So, we know that 3 is one of the factors. Now, what about 5? Well, once again, 5, well, when you multiply any number by 5, it always ends in a 5 or a 0. None of these numbers end in either a 5 or a 0, thus making 5, a discardable number. We don't need that right now to find the greatest common factor. Alright. What about number 9, you might ask? Well, we should probably do number 7 first, because I know many of you saw that 63 and immediately thought of dividing it by 9, but let's see number 7 just in case, right? 63 divided by 7 gives you 9, 84 divided by 7 gives you 12, and then 252 divided by 7, well, that gives you 36. That's interesting, right? So, we know that 7 is also a number that all of these numbers are divisible by. Now, we have the last single digit number, right? We have one more single digit number that's odd, which is number 9. But here's something you should look at first, right? If you look here, 84 is an even number, 252 is an even number. That means that number 9 cannot, you can't divide 84 by 9 and get a whole number. That's impossible. So, just like that, we only know that all these numbers can be divided by 3, all these numbers can be divided by 7. Now, how do we find the greatest common factor with these two numbers? Simple, you just multiply them. So, we know that the greatest common factor of these 3 numbers is 21. Now, what do we do with this number we got? We got it, but what do we do with it? Well, we can divide all of these numbers by 21, right? So, 63 divided by 21 is 3, 84 divided by 21 is 4, and then, let's see, well, 12. So 12 times 21 gives you 252. Alright, so now we simplified it like this. Now, you're probably wondering, now what do I do with this? You didn't make it harder, you didn't make it easier, it's just, you simplified it. We still have to computate that, right? Here's the interesting part. Now, you ever notice that a squared plus b squared is equal to c squared? Now, if you're like me, you're probably looking at 3 squared plus 4 squared. 3, 4, and 5 are they're the smallest and most known Pythagorean triples. So we're actually using Pythagorean triples here to simplify this equation even further. Right? 3 squared plus 4 squared is equal to 5. 5 is the, hypotenuse of a triangle. This is something, very common. You probably would have learned it in geometry. Now, we simplified that equation to 21 squared times 5 squared plus 12 squared, right? Now, 5, 12, and 13 are also Pythagorean triples, so we can logically simplify this to the square root of 21 squared times 13 squared. Now, since we're multiplying these numbers and not adding them, we can simply just find the square root of each number, which is literally 21 times 13, right? So what is 21 times 13? Well, let's find that out. 21, 13. After, multiplying it, you will find out that we actually have 273 as the answer. Now, is 273 an answer choice? Well, looky here. It certainly is. So, your answer for this question would be 273.